Okay, let's take a look at this price discrimination problem. If you haven't already, you can download a copy of this just by clicking on the link above and printing it off. It'd probably be helpful to do that. Here we have a firm that sells a product in two markets, Market A and Market B, and the demand schedules for each market are given in the table below. Fixed costs are $12,000 and average variable costs are constant, equal to marginal cost of $3 per unit. So we have the two markets, Market A, Market B, and the first part of this problem says suppose the firm can separate the two markets, charge a different price in each market. What would be the optimal quantity and price in each market, and what would be the total profits earned? So we have some work to do. The first thing we need to do, since we know our costs are constant, $3 marginal cost, $3 per unit, we need to be able to compare that to marginal revenue. To get marginal revenue, we need total revenue. So the first thing I'm going to do is to convert this demand schedule to total revenue. Total revenue is simply price times quantity. So 36 times 0 is 0. Now we have to break out the calculator. 30 times 475 is 14,250. 24 times 900 is 21,600. Might want to check. Just do this on your calculator, make sure the work is correct. 18 times 1100 is 19,800. Now you'll notice something. Total revenue just started to fall. That means from here on, marginal revenue is negative. We never produce where marginal revenue is negative. So I don't really need to go any further. I can just leave the rest of these blank, at least as far as to answer the remainder of this question. So I'm just going to stop there on total revenue and then go to the marginal revenue. Now, this is one of those where you have to be really careful. Marginal revenue is the change in total revenue divided by the change in quantity. Quantity is not increasing by increments of 1. In fact, for this first marginal revenue, we take the change in total revenue, which is from 0 to 14,250. It's a difference of 14,250. And quantity increases by 475. That gives us a margin, if you work through the math, of 30. Marginal revenue is 30. Similarly, for the next margin, we take the change in total revenue from 14,250 to 21,600. That's a difference of 7,350. Quantity increases by 425. And so let me just check that real quick. 7,350 divided by 425 is, it looked a little strange. I wanted to make sure I got it. 17.3, 17.29 and some change. So, and again, from here on, we don't really need to compute the margin because it's negative. We can actually, we can pause here for a moment. Since we know that marginal revenue is 30 and then 17.3 and then it becomes negative, marginal cost is a constant $3, we can use the profit maximization rule. In Market A, to maximize profits in Market A, we're going to choose the highest level of output at which marginal revenue is greater than or equal to marginal cost. Well, where is that? The highest level of output where marginal revenue is greater than marginal cost is at 900 units. Marginal revenue is 17.3, marginal cost is 3. Anywhere beyond that, marginal revenue is negative, be less than 3. So in Market A, in market A, the optimal quantity is 900 units, and the optimal price is $24. Again, that's our point on the demand curve. We can go ahead and just make note that total revenue is $21,600. That's our revenue generated in market A. Okay, so market A, we're going to charge a price of $24, sell 900 units. Now go to market B. We're going to go through the same process in market B, computing total revenue and marginal revenue. Total revenue is price times quantity. So if you don't mind, I'm going to just compute these numbers at 1,050, 6,000. Okay, now notice what just happened. The margin became negative. So there's no use in going any further. We never produce where marginal revenue is negative. So we can now compute our margins. 750 divided by 25, that's 30. And you might want to just check me, make sure I'm right here, but I believe that's the margins. And again, we can use the profit maximization rule. Marginal cost is 3. The highest level of marginal revenue, it's greater than or equal to marginal cost. There it is. So the optimal quantity in market B would be 700 units and a price of $12, and that generates revenue of $8,400. Now, this question wants to know what our profits would be. Again, we're price discriminating. We're charging different prices in the two markets. If we add market A's revenue, $21,600, to market B's revenue, $8,400, that gives us total revenue in the two markets of $30,000. 21,600 plus 8,400, that's $30,000. Minus our costs. Costs are fixed, $12,000. And then variable costs are $3 per unit. Remember, we sold 900 units in market A, 700 units in market B. That's a total of 1,600 units, 1,600 units at $3 a piece. Okay, and so that's $4,800 in variable costs. These are my fixed costs, and these are my variable costs. Again, I took the total number of units sold, 900 in market A, 700 in market B. That's a total of 1,600 at $3 per unit. Gives me $4,800 in variable costs. And so, to get profit, we subtract out the variable costs, the fixed costs, and let me just check my work one more time. Don't want to get this wrong. 30,000 minus $12,000 in fixed minus 4,800. That gives us a profit, and I'm running out of room, but I'll just write it here. Profit of $13,200, and this is profit with price discrimination, charging a different price in each market. Now, I'm running a little long, so I'm going to stop this, and in the next video we'll look at the last part of this problem.